This video is going to be on atoms, the first iteration of what we thought about atoms, and that comes from the Greeks and from an English Quaker named John Dalton. This material is covered in the second chapter of the OpenStax chemistry text, second edition, but it's also in the first edition. Okay, so atoms are building blocks. Everything around you, the air you're breathing, planets, stars, everything is composed of atoms. A very good analogy for atoms is Legos. So if you've got a whole bunch of Legos, you can build whatever you want. And the cool thing about the Legos is once you've used them to build something, you can disassemble the Legos away from each other and then use them again. That's one of the things that makes them great. And that's the same situation with atoms. So if carbon dioxide from the air is combined with water inside of a plant and photosynthesis is allowed to happen, that CO2 and H2O, those molecules will be disassembled and put back together as oxygen, gas, and carbohydrates like glucose. So all we're doing is pulling things apart and putting them back together. And that's the chemistry of it. So when we're talking about atoms, there are many different types, and the periodic table shows you all the different types that we know. And if we're talking about an element, we're talking about one specific type of atom. So hydrogen is a type of atom. Carbon is a type of atom. Oxygen is a type of atom. Gold is a type of atom. But if I put those things together, I can make whatever I want, in the same way that there are red Legos that have 6 nubs on them, and red Legos with 4 nubs on them, and blue Legos with 2 nubs on them. So they come in all kinds of iterations, but they're still objects that can be put together and taken apart and then put together in different formations. The 3 fundamental particles are going to be the proton and the neutron and the electron. These things can be broken down further, but for our purposes, protons, neutrons, and electrons are all we're going to need to deal with chemistry. In the same way that a Lego is actually composed of polymers, different types of plastics, and dyes, and you could disassemble those, but then it is no longer itself. So if we were to disassemble an atom, it would no longer be an atom. All right, so the protons are positively charged. The neutrons have no charge at all, and the electrons have a negative charge. And the charge that's positive on the proton and the charge that's negative on the electron, they're equal in magnitude. So if you've got one proton and 1 electron and you put them next to each other, the overall charge of that turns out to be 0, and that would be a hydrogen atom. The protons in the nucleus and the neutrons are located in the middle of the atom, called the nucleus, and the electrons orbit around the exterior. And the orbit is kind of complicated, but they are on the outside. An easy way to think about it is in the same way that planets orbit around the sun, but it's certainly not that simple. And this last thing here, AMU, is called the atomic mass unit. The atomic mass unit is a very, very small mass, and that very, very small mass, if you were to take a single carbon atom that has 6 protons and 6 neutrons and then divide its mass by 12, that's the atomic mass unit. So it's 1/12 of a carbon atom. So it's approximately the size of 1 proton or 1 neutron. The electron is so much smaller. It's 8,200 times smaller that we don't give it a mass in chemistry. So if I've got an atom and it loses or gains an electron, its overall mass doesn't change significantly enough for it to matter. In the same way that if a bug hits your windshield and sticks, your car it does technically gain mass, but it's not important. It's not going to like change your miles per gallon and then adversely affect your vehicle. This concept of the atom might have been thought of before the Greeks, but the first people to write it down were the Greeks. Democritus and Leucippus are the first two. Leucippus was Democritus' teacher, but Democritus is the one that seems to have written the most about it, definitely written the most about it. And I think it was more Democritus bouncing ideas off of Leucippus, coming up with this idea of the atom. The other people who you can lump in with this idea would be Aristotle. Although he did not believe in atoms specifically, some of his concepts about what things are made of kind of helped push this along. And then Epicurus, he really took Democritus' ideas and laid groundwork with them, not just about the idea of what they consist of, but also about how people should think about that philosophically. This was around 440 BC that Democritus came up with his first work, writing this down at least. And so you can think about what 440 BC was like for most people: farming, fishing, working for people who had money, soldiering. I guess sheep herding would be a thing, but it was very difficult for a person to live in 440 BC. And so here's Democritus and Leucippus coming up with this idea of atoms. So they were children of people with money, so that allowed them. So these are just like rich kids thinking about this stuff. Epicurus, what I meant by moving the philosophy of people along was when he thought of this idea of atoms, he thought, okay, so everything's made of these atom things. And so that means I'm made of them, the street is made of them, the sky, dogs, everything's made of these atoms. So that means I'm not special. I am not a chosen creature of God. So his ideas of what people should do with their lives was a direct threat to the church at the time, all churches. So they hunted him down. After about 10 years, they caught him and burned him at the stake in the middle of a town to let everybody know that blasphemy is not allowed. And that's the first reason that it took so long for us to move this idea of what atoms are along, because the first couple of people were not taken seriously, and the one that was taken seriously was taken as a threat, and they killed him. So if you're a philosopher, you're probably not going to think about that kind of stuff because you do not want to be burned at the stake. It took more than 1,000 years for anybody to publicly talk about Epicurus' writing. Oddly enough, it popped up in a monastery in Europe, and it was found by the person who was the secretary of the Pope, which was a pretty important position at the time. And he was actually looking for Epicurus's work. So that was fortuitous that he found this treaty that Epicurus wrote. Epicurism has been morphed into something called hedonism. That's not anything that Epicurus would have agreed with. Epicurism as a philosophy of life is live your life well, be a good person, and do not live for an afterlife, because there isn't one. We're all atoms, so you're going to end up turning to dust, and that dust is going to turn into different stuff like trees and other animals and whatnot, rocks. So yeah, we've got these guys, they come up with these ideas. And so let's talk about some of the parts of their theory. So some of them are correct, some of them are incorrect. So all matter is composed of atoms, which are bits of matter too small to be seen. This is true. This is true to today. We have not been able to see an atom, and unless things really change with our understanding of quantum mechanics, we will never be able to see an atom. As the act of looking at an atom moves the atom. We can look at each other because we're not an atom, we're lots of atoms. Okay, so everything's atoms and they're too small to be seen. Great. Atoms cannot be split into further smaller portions. Well, we already know that's not true because earlier we talked about protons, neutrons, and electrons. Atoms are completely solid. They are not completely solid. We're going to find out that they're really hollow, actually. They are homogeneous with no internal structure. Also not true. We know that there's protons, neutrons, and electrons, and that they have specific positions within the atom that they reside. All atoms are different in their sizes. That is true. All atoms are different in their shapes. That is not true. They are same, actually. Even the small ones and the large ones, they're all the same. And they're different in their weights. That is also true. So here we are. People can't keep water clean. People are dying of microscopic organisms because they don't understand what disease is. You get poked by a stick, you got a 50-50 chance of losing that limb and a 25% chance of just right out dying because you got poked. Yet half of the things that they thought of were true. So that thought process worked out. All right, so we do not get anything new out of this. So we're talking 440 BC, and then in about 1800, so that's 2200 years later or so, John Dalton comes out with an idea of what the atoms are, publishes it, people read it, and they understand, they like it, and he makes a couple of modifications to his theory, the theory that the Greeks came up with. John Dalton was a Quaker who lived in England. He had a lot of free time, but he also lived super modestly, so he wasn't interested in a lot of fame with this. It was something he wasn't interested in. He just did little tests on things, and for instance, he took a water molecule and ran electricity through it because batteries were a thing, and he found out that you got a 2-to-1 proportion. And so that became part of his idea of what atomic theory is. So first off, all matter is composed of extremely small particles called atoms. So stole that directly from the Greeks, totally true. Atoms of any given element are identical in their size, mass, and properties. So the size is true, the properties is true, but the mass is not. You can have two gold atoms that are identical in size and properties, but their mass is different. And we'll talk about isotopes a little bit later. Not in this video, but in another one. Yeah, so all carbon atoms are exactly the same in their properties. So that totally makes sense. We talked about that in chapter 1 information. Okay, atoms are of different elements are different in their size, mass, and properties. That is true. They are different sizes, they are different masses, and they have different properties. So gold and copper are not going to have the same size, mass, or properties. They could have similar properties, but not the same exact. Atoms cannot be subdivided, created, or destroyed. So we know this one's not true because we can atom smash and separate them, but we also know that the atoms are protons, neutrons, and electrons. In a chemical reaction, okay, so let me wait for a second. These last 2, 5 and 6, are the crux of Dalton's theory. So coming up with these 2 ideas are what allowed science to move forward, take a huge jump forward. In chemical reactions, atoms are combined, separated, or rearranged. That was massive. This is the Lego concept, that I have these atoms and I run a chemical reaction, and all I did is I had some stuff in molecules, I pulled them apart, I put them back together differently. Nothing happens to the atoms. That's the most important part. When you're watching a piece of wood burn, you're seeing atoms that are connected together in a specific way, disassemble, and then reassemble into another formation. But the atoms themselves are fine. The carbon that's in the glucose that's in the wood, the cellulose of the wood, disconnects from the other carbons and oxygens and hydrogens and comes back together with different oxygens and forms carbon dioxide. So that is what is happening. I'm simply disassembling and putting them back together. Or it could just be disassembling, or it could just be putting them together. But whatever, the atoms are different in how they're connected or not connected. And then the last one here, atoms of different elements combine in simple whole number ratios to form chemical compounds. Sometimes they'll create more than one compound with differing ratios. All right, so the easiest one with that one is water and hydrogen peroxide. So water is H2O and hydrogen peroxide is H2O2. They're both just hydrogens and oxygens, but this one, love this one will make you puke. Cleans out a wound really well for you, disinfects a wound, but you cannot drink it. You will vomit with like a cap full of it will make you vomit. So these are both hydrogen and oxygen, and they're different molecules, and they have specific ratios. And if I have anything that's two H's and an O, that's water. And anything that's different, like 2 H's and 2 O's, that's not water. So that is his idea of definite proportions. The ratios are exactly the same. And the cool part about it is they're simple whole number ratios. It's never going to say H 2.870 1.93. It's going to be whole numbers. It's either an entire atom or it's not an entire atom. They could get big. A bigger one would be C6 H12O6. That's larger, but it's still just 6, 12, and 6. And so again, this definite proportions this is always carbon dioxide, CO2. 2 C's and an O, or 2 C's and 2 O's, those are not carbon dioxide. So even though they're just carbons and oxygens, they are not in the same ratio. So they need to have different properties or not exist at all, which actually neither of those exist. If they do, I don't think either one of those exist. Okay, so because of these two, chemistry and science had a foundation. So before, you look at something and you don't know what it's composed of. What is that rock made of? What is that piece of dirt made of? What is my hand made of? And so now we have the idea that, okay, these are all composed of atoms. Is there ways I could disassemble them? And that's what they started to do. Started to apply electricity specifically to things and have them disassemble from each other. So like if you want to get aluminum to make an aluminum can, you would take rock that has aluminum ion in it, and you put electricity through it. And you'll heat the rock will melt, and the actual aluminum will gain some electrons and become aluminum metal. And they were doing this with rocks and other objects, salts, and coming up with substances. And this idea could not, those processes never would have been thought of if everybody hadn't been thinking about chemical reactions being atoms that are simply combined, separated, or rearranged. So this modest Quaker, John Dalton, really pushed chemistry and science in general forward. Something that was holding chemistry back for a very long time was this concept of alchemy. And alchemy is the idea that you can create a substance, and that substance can turn other substances into rare metals. So you could take this thing and create it and then touch it to copper, and the copper would turn into gold. That's not a possibility. You're changing the number. When you do that, you're changing the number of protons in something. And we have done that, but it was monumentally expensive, and we only made a handful of atoms, like, I don't know, less than 10. So we're not going to do that again because it doesn't make any sense. This painting is something, a painting by a guy named Joseph Wright, and it's called In Search of the Philosopher's Stone. And so this guy here is an alchemist. He's trying to create the Philosopher's Stone that when you touch it to a base metal like copper or iron or something, it turns it into a precious metal like gold or silver. These poor guys here, these kids back here, they have a job to do. And the job, this guy is telling them he needs stuff, and he's going to put it in this container and heat it up. So what the alchemist thought was that life could give, you could make this Philosopher's Stone out of things from life. And so this is a Florence flask filled with urine. And so these poor boys had to walk around town and say, hey, will you pee in this bucket? And then they'd bring it back here, and he would dump it in here, and then they would boil it. So you can imagine what that room smells like, boiling human urine. If you boil it enough, you reduce the water content of enough urine down, you'll create some phosphorus in a concentrated amount, and that phosphorus, when heated, will glow. So this glowingness that they're misconstruing as something that has to do with life is literally just glowing phosphorus, because the phosphorus is hot and it's concentrated. So because of this alchemy thing, it took a long time for people to understand and get a base for true science. That and, killing the people like Epicurus who were trying to explain what atoms were. Those two things really slowed down science in general. And that is all I've got for this video. Thanks.